This is Ashutosh Garg here from Furnace Improvements once again, and we are going to be talking about a question we received from one of our participants in the webinar session. The question relates to vacuum heaters, and it talks about what is the preferred location of process outlets in a vacuum heater. Very good question. So I took this question and I will try to answer it to the best of my capabilities. So vacuum heater, as you know, is the second heater in the refinery. It comes after the atmospheric heater and crude heater, and whatever is at the bottom of the atmospheric unit is sent to the vacuum unit for distillation under vacuum conditions. So vacuum heater kind of experiences higher temperatures, almost close to 430, 440 degrees centigrade or 800 degree F. That's typically 770, 800 degree F. And one characteristic which is different from any other heater is that there is vacuum present at the outlets. So as a result, the vaporization is much higher, and that vaporization is used to distill the vacuum feed into various products. So the distinction being it has high temperature, and once it is high temperature, it is prone to cracking. So the film temperature becomes important. Then it has low pressure, so because of low pressure, we are forced to use tubes of higher diameters as compared to the rest of the coil. So we end up using last 3 tubes or 4 tubes depending on the actual design of the heater, which are larger and which basically make sure that the peaking does not occur. That means the bulk temperature does not go high, and that leads to cracking. The third thing which is present in vacuum heaters is injection of steam. So we inject steam to increase the vaporization and reduce partial pressure of hydrocarbons. Typically about 0.5% to 1.5% of steam by mass is added, and that does the trick, increases vaporization. So that's basically a little bit about introduction to vacuum heater. So there are two types of heaters, as you all know, and I'm showing a vertical cylindrical heater here. Historically, almost all vacuum heaters were made horizontal heaters, horizontal tube cabin heaters. But in the last 30 years, 40 years, I think there are a lot of vacuum heaters which are in vertical cylindrical configuration. So if it's a vertical cylindrical configuration, the choice of outlets is not there because all the tubes are arranged in a circumference, and most of the time the outlets will be at the top of the radiant section. And that is good also because the transfer line or the line which is pipe which is connecting the vacuum heater outlets to the vacuum column is called transfer line, and the design of transfer line is very complicated because you want to have very low pressure drop and the correct flow, all those type of things, and it's very large diameter. So those things lead, if you have a vertical cylindrical heater, it will be good for you because the line is going to be short, because vacuum column inlet is going to be almost at the same location as the radiant section outlet, so you can have a short transfer line. The question comes when we have a horizontal tube cabin heater. That's where we can have the outlets at the top, we can have the outlets in the middle, and we can have the outlets at the bottom. The advantage of having the outlets at the top is the transfer line will be minimized because it's going to go to the vacuum column. But depending on the box configuration, it could be that the outlets are in the hottest zone of the radiant section. Radiant section, even though we say is continuously stirred tank reactor, it's never the case in actual. So what happens is we get different heat distribution patterns in a heater. And I'm showing you a heater over here which we revamped several years ago, and you can see it has 4 passes, downward flow, and this heater was coking a lot. Not only coking a lot, the other issue becomes that the top 2 passes may be getting a lot more heat than the bottom 2 passes, or vice versa, depending on the type of burners, If you have ultra low NOx burners, the top 2 passes will be overheated. If you've got standard burners, then the lower passes will be overheated. So this heat distribution pattern has been a major issue in vacuum heaters and any multi-pass cabin heaters, So now the question comes, what can we do? I mean, we can have a 4-pass heater. We can have the outlets on the top. That is one option. The second is we can have the outlets, as we are saying, 2 in the middle, 2 in the bottom. That's another option. We can have all the 4 passes in the middle. That way the bottom 2 passes will be upflow and the top 2 passes will be downflow. So all the 4 passes are in the middle. So that is another option you can have, And also you can have all the 4 passes at the bottom. So the question is, what is the best arrangement for vacuum heater outlets? So let's talk about this heater which we revamped for a client in the US. And what we did was we provided the vacuum heater outlets at the bottom. We were having ultra low NOx burners, and ultra low NOx burners generally have long flames. So as a result, what happens is the upper section is hotter and the bottom section is cooler. So we decided to put the hot tubes at the bottom so that they don't get too much heat. Also, what we did was we nested the passes. We have 2 passes running concurrently on each wall. So it's a 4-pass heater, so the 2 passes run side by side on one wall and the other 2 passes run on the other side. And as a result, what happens is all the 4 passes are uniformly heated. So if you have a heater, if you are thinking of going for a vacuum heater, talk to us. We can design the best heater for you. That's my personal guarantee. And if you have a heater which is having issues like tube metal temperatures, coking, again come to us and we'll be able to fix your heater and make it from worst heater to the best heater. Thank you. Hope you enjoyed my presentation and see you next time. Please give us your comments.